Alright, welcome college algebra trig class. This is a class dealing on sine and cosine functions and some of the other trig functions that we're going to be covering in trigonometry. This is section 5.2, circular functions. The sine and cosine functions may be familiar to you already from right triangles. We're going to come at it from a different approach using what we call a unit circle. By that I mean a circle which is centered at the origin with radius 1 unit. The units can be anything you desire, and really it's irrelevant here. Could be inches, could be centimeters, whatever you wish. It's just 1 unit in radius. So if I pick a point on the unit circle, any point, and give it an address, I could give it an XY coordinate as an address, a unique address, and with that point I can associate an arc length that's on this unit circle. In other words, if you start at the point 1, 0 on the unit circle and go counterclockwise, you can measure off the length of arc to that point XY, and you can call it lowercase s, which is custom. So s represents the arc length from the point 1, 0 to this point that we picked XY, and this number can be associated with that point on the unit circle. In fact, every real number, s, determines a point on the unit circle. If it's a large real number, for example 1000, you could go around the unit circle more than once. As long as you go a distance of 1000 units around that unit circle, and then wherever you would end up, that's your point associated with that arc length. Alright, so every real number, s, determines a point on the unit circle. Now, to this number s, you can associate the y coordinate, and you call that sine of s. So the sine of s is equal to the y coordinate of the point that goes along with that arc length. Right? And cosine, C-O-S-I-N-E, of s is the x coordinate. The abbreviations for sine and cosine are SIN. So SIN-S equals y, sine of s equals y, and COS, or cosine of s, is equal to x. Now, if you've covered right triangle trigonometry before, you may be familiar, like I said, with sine and cosine, and let me give you a preview of what we're going to be covering later. We will cover right triangle trigonometry later on, but to satisfy any questions you might have right now, I'll draw a right triangle in there. All right. And the angle in this right triangle at the origin we'll call angle theta. It turns out that angle theta is equal to this arc length s, as long as we have a unit circle here. And this side of the triangle, this leg, is x, and this side of the triangle is y, because that's the point xy. So you've got x units on the x-axis, y units on the y-axis. There's your point xy. Alright? So basically you have this right triangle, and by the way, the hypotenuse is actually the radius of that unit circle, which clearly is 1. So here's theta, here's your right angle, here's x, or rather that's y, and here's x, and here's 1 unit of radius. So if you've covered this before, the sine of theta is equal to side opposite of theta, which is y, over the hypotenuse, which is 1. So sine theta equals y. And the cosine of theta is x, side adjacent, over 1, the hypotenuse. So cosine of theta is x over 1, or x. So it's consistent with our definition, and we'll get back to this in more detail later. Alright, so let's find some sine and cosine values of typical angles, or typical S values. So how about cosine, or rather sine of 0 and cosine of 0? Here's a unit circle. Well, 0, that means an arc length of 0. Alright, so I want the sine of 0. So S is equal to 0, arc length of 0. What's the sine of 0? Well, what's the coordinates of this point? That would be x equals 1, y equals 0. So we said the sine would be the y coordinate associated with that arc length of that point. And so sine of 0 is 0. That's the y coordinate there. Cosine of 0 is the x coordinate, which is 1. So the sine of 0 is 0, cosine of 0 is 1. What about pi over 4? Well, the distance pi over 4 is halfway across this arc length here, covering the first quadrant. You can take my word for that right now. So there's pi over 4 arc length. Right. The coordinates, you'll have to take my word for this now. We'll develop this more in detail later. The coordinates of that point are square root of 2 over 2, square root of 2 over 2. And so the sine of pi over 4 is square root of 2 over 2, and the cosine is also square root of 2 over 2. Alright. So again, this is halfway across this first quadrant here, covered by the unit circle. So if that's pi over 4, then add another pi over 4 to that, and you'll get to this point right here on the y-axis, the y-intercept there. And that has coordinates x equals 0, y equals 1. So that's pi over 2 units in arc length. Right? From here to here on the unit circle is a distance of pi over 2 units. So the sine of pi over 2 is 1, and the cosine is 0. Alright, now what about some other common angles? Let's take a look. Draw a new unit circle here. Let's look at pi over 6 and so forth. So pi over 6 would be right about there. That's the arc length of pi over 6. Let's go all the way around. So this is pi over 6. And then 2 pi over 6 would be right about here. 2 pi over 6 reduces to pi over 3. 3 pi over 6 reduces to pi over 2, so we've already seen this point before. And we have 4 pi over 6, which is 2 pi over 3 actually. So that's 2 pi over 3, or 4 pi over 6. Then you got 5 pi over 6. 6 pi over 6, which reduces to pi, and that's right there on the x-axis. So that's 6 pi over 6, you got 7 pi over 6, 8 pi over 6, which reduces to 4 pi over 3, 9 pi over 6, which is 3 pi over 2, 9 pi, and then you got 10 pi over 6, which is 5 pi over 3, and so what do you got? 10 pi, 11 pi over 6, right? 11 pi over 6, and then 12 pi over 6 is 2 pi, that's right there. 2 pi, or you can think of that as 0 as well. Alright, We can also divide it up into fourths. We got pi over 4, 1 pi over 4 or pi over 4, 2 pi over 4, which is pi over 2, 3 pi over 4, 4 pi over 4, which again is pi, 5 pi over 4, and 6 pi over 4, again that's 3 pi over 2, 7 pi over 4, and then 8 pi over 4 is again 2 pi. So we've got these commonly referred to points on the unit circle or arc lengths on the unit circle, and let's put some of the coordinates on here. Right now you can take my word for this. Later we'll develop this in detail. But pi over 3 has coordinates 1/2 square root of 3 over 2. Pi over 4 is square root of 2 over 2, square root of 2 over 2. And pi over 6 is square root of 3 over 2, 1/2. And of course we have, these are easy to determine coordinates. That's the point 1, 0 at 2 pi or 0. And up at pi over 2, that's the point 0, 1. With these points you can get all of the other points on the unit circle just by reflecting. For example, if you want to know the coordinates for 2 pi over 3, you just reflect this over to here, and what do you get? Well, the same x value, except it's to the left of the y-axis, so it's going to be a negative x value. That's negative 1/2. The y value is the same, negative 1/2, and square root of 3 over 2. And you can repeat this process, reflecting. You can reflect all the way across also. Reflect all of these points, and you can determine the coordinates of all of the other points. Now, this is done for you in the back of your book also. If you look in the back, you've got this unit circle. It's got the, these are called radian measures. These arc lengths are radians. You also have the degrees that correspond to the radians, and you have the coordinates. These are the what we call special angles. They're commonly used in trigonometry. And there are other circular functions as well. We'll get to those in a second.